Other question of the ray optics, an optical fiber having refractive index 1.72 is surrounded by a glass coating of refractive index mu is equal to 1.5. Find critical angle for total internal reflection at the fiber glass interface. See the diagram here. This is the your refractive index is 1.72. Here it is refractive index is 1.5, that is of glass, right? So total internal reflection, we have to find the critical angle. So basic, in case of the optical fiber, this is what optical fiber. In case of the optical fiber, you remember the total energy remains intact. So here this is a denser and this is a rarer. So a signal or the energy is not transmitted to the another medium. So anyway, our purpose is to find the critical angle for the total internal reflection at the fiberglass interface. Interface means the surface which separates the two medium. So according to the formula, we have to write sin I, Snell's law, sin I by sin R is equal to mu2 by mu1. So here in this case we are going to apply sin I. So definitely critical angle is there by sin 90. Critical angle is a particular angle of incidence for which angle of reflection is 90 degree. That should be equal to the here it is given 1.5 mu2 by 1.72. So directly we can find out sin 91. So sin C is equal to 1.5 by 1.72. So if you are going to calculate, you will get 75 by 86. If you are going to cut it, so C is equal to sine inverse 75 by 86. If you are not knowing the value, better to write like that. That should be your answer. Another question, find the angle of deviation suffered by the light ray in figure. The refractive index is mu is equal to 1.5 for the prism material. Here it is this is a diagram. Prism is there. Here this is 90 degree. Here it is 4 degree given. So what happens? An angle of your prism is given. This angle is given 4 degree, right? So our purpose is to find the angle of deviation. So here refractive index is given 1.5. An angle of prism is 4 degree. That's a very, very small. And here the basic, if the angle is small, you remember sine theta. If theta is small, then sine theta becomes theta. That basic is required. However, another very important formula is there. हम लोग formula का use करेंगे prism के लिए. Mu is equal to sine A plus del M by 2 by sine A by 2. What is here del M? Del M is your angle of deviation. So put the value sine 4 plus del M by 2 by sine 4 by 2. Now you have to just calculate it and you will get it. So value will be mu is equal to sine something around 1.5 that its value will be, if you are going to calculate with the help of because mu is given, just find out the value. How you are going to find out the value? In this way, as a del m is you have to find out. So better is to write 1.5 is equal to sine 4 plus del m by 2 by sine 4 by 2. That is 2. So you just cross multiply 1.5 into sine 2 degree is equal to, you will get the sine 4 plus del m by 2. So sine is so this is equal to sine inverse of this. By putting the value, you will get del m is equal to 60 degree. Just you put the value and get the answer. It will be around 60 degree. Actually, if you are going to calculate, not exactly the 60 degree, but the how you are going to calculate, just to see, in this way, इसको ऐसे ही कर सकते हैं. That is your mu is equal to कितना आया यहाँ के बाद sin 4 plus del m by 2 by sin 4 by 2 इतना आया था. तो angle is small, so we can remove the sign also. So we can write mu is equal to 4 plus del m by 2 by 2, like that. And from here you can easily find out del m is equal to 4 degree into 1.5. Just you calculate, minus 4 degree, that is equal to 2 degree. Del m will be 2 degree. That should be the answer. This is not the way. After find out this particular way, this, as the theta is small, so this angle is small, so we can replace sine theta as a theta. So this is the way. So the correct one is this. Mu is equal to this much, sine this much, sine this much, and we are going to remove the only writing the angle, because sine theta becomes theta, and then cross multiply and you will get it. That should be your answer. Another question: a point object is placed at a distance of 15 cm from the convex lens. The image is formed on the other side of a distance 30 cm from the lens. When a concave lens is placed in contact with the convex lens, the image shifts away further by 30 cm. Calculate the focal length of the two lenses. Here the two lenses are there, convex and concave. All the details are given. So here, let u be the object distance from convex lens. कैसे इसको सॉल्व करना है, देखिए u क्या है, ऑब्जेक्ट डिस्टेंस कन्वेक्स लेंस के लिए. जब केवल कन्वेक्स लेंस था, कनकेव बाद में हम लिखे हैं यहाँ पर. So and v1 will be the image distance from convex lens only. v1 इमेज बना जब कनकेव नहीं था, केवल कन्वेक्स था. v1 f1 will be the focal length of convex lens. f1 be the focal length of the convex lens. Then we can write 1 by v1 minus 1 by u is equal to 1 by f1, thin lens formula. So here put the value 1 by f1 is equal to 1 by 30 minus 1 by minus 15, that is 1 by 15. So therefore f1 will be 10 centimeter. f1 कितना आएगा? 10 centimeter. Take LCM and this 10 centimeter. f1 आ गया. f1 क्या? f1 क्या है? कन्वेक्स लेंस का फोकल लेंथ, वो निकल गया. Now let v be the image distance from concave lens. अब concave lens को हम प्लेस किए and that will be the 30 plus 30, it is given 30 centimeter shift हो रहा है further away, that is 60 centimeter. And मान लेते हैं v1 be the object distance from concave lens. concave lens से object distance v1 है, right? And that is your given plus 30 meter given in the question. And let f2 be the focal length of concave lens. यही हमको निकालना है, concave lens, यही चीज़ हमको निकालना है. So we can write again 1 by v minus 1 by v1 is equal to 1 by f1. So by putting the value 1 by f1 is equal to 1 by 60 minus 1 by 30 here it is f2 जब लिए तो यहाँ पर f2 होना चाहिए, f2. So therefore take the LCM, 60, 1 minus 2, that is your minus 1 by 60. So f2 will be minus 60 centimeter. तो ये कनकेव लेंस का फोकल लेंथ निकल गया. सो कन्वेक्स का फोकल लेंथ आया कितना? 10 सेंटीमीटर. एंड कनकेव का फोकल लेंथ आ गया 60 centimeter. That should be your way of doing it.